Okay, so today is going to be a quick video, hopefully. It's only a 2-marker question, but as you will see, it's not as easy as you think it will be. This is a question that was requested by one of my students. Okay, so let's get down to it. So this question is, as I say, it's not as simple as initially you think looking at the number of marks. So for example, it's only 2-marker, but if you look at it, so you'll need to know quite a bit of sort of other chemistry knowledge to be able to answer this question. So for example, you need to know about carboxylic acids, you need to know about how they react with alcohols, you need to know obviously the products when this reaction happens, and you need to know the time of flight mass spectrometer. So the time of flight mass spectrometer content is usually taught in year 1 or year 12. Okay, but carboxylic acids and esters, maybe I've given the game away, but esters, okay, is usually taught in year 2 or year 13. But you will need to know all of these bits of knowledge to be able to get these 2 questions, which is why I said it's not as easy as you think. Okay, so what I'm looking at is my thinking process is, okay, well, first of all, it's an obviously oic acid, so it's a carboxylic acid, but it's a dioic acid. So do I know what ethandioic acid looks like? Excess of an unknown alcohol, so obviously they've not given me which alcohol it is, so there will be some guesswork there. The products of the reaction were separated and analyzed so the products were separated. Okay, were analyzed in the time of flight mass spectrometer. 2 peaks were observed with MZ, so mass to charge ratio, so you'll need to know a little bit about those as well, of 104 and 118. Now initially, when I looked at this question, I'm thinking, oh yeah, time of flight, ethandioic acid, mass to charge ratio of 104 and 118. Let's look at ethandioic acid, what that gives me. But what you got to realize, it's not ethandioic acid, it's actually the products of this reaction. Okay, so how would I approach this question? The question is, identify the species responsible for the 2 peaks. Well, let's show you. So the first thing that I'm going to do is try and visualize in my head, what does this ethandioic acid look like? Okay, so ethandioic acid, right, so I'm going to start drawing ethandioic acid. So ethan, so obviously 2 carbons, and oic acid means it's obviously a carboxylic acid. And this is going to be, and I'm not going to draw the H here just yet, okay, as you'll see in a minute why. But then it says, so this is what the ethanoic acid will look like if I had a H there and H is there. But it says ethandioic acid, so that means there's 2 carboxylic acid functional groups. Now the only other place where another carboxylic acid functional group could be is on this carbon. So it's going to be, I'm going to have to draw carboxylic acid functional group on this side as well, which is, and if it was a carboxylic acid, it would be another H there. If I had a H there and a H there, that would be ethandioic acid. Okay, but the reason why I'm not drawing it yet is because obviously they're reacting this with something else. So I don't know whether it is this or is it changes or is there something else. Yeah. Okay, so if you react it with alcohol, now you should have been taught this. So this is one of those synoptic type questions where in this 2 marks, the examiner can test quite a variety of your knowledge, chemistry knowledge. Okay, so, and of course this question would have been given after you've been taught all of this. So you should have known that when these carboxylic acid react with alcohols, what you actually end up getting is you end up getting an ester. All right, now which ester, so an alcohol group here, an alcohol group here, but we don't know which alcohol it is, so I can't draw it. Okay, so this is now where I'm going to be looking at my mass to charge ratio. So I've been told that there are 2 peaks. One is MZ, mass to charge ratio of 104. And so what I want to do is I'm going to say, well, okay, the mass of this product of this reaction is 104. Right? But what is the mass of this? Then I can look at the difference, can't I, between 104 and the mass of this, and then decide, well, how many alkyl groups go here to make up 104. Okay, so that's what I'm going to do. I'm going to look at the difference between the MZ peak and this dioic part. Okay, so let's do that now. So all you do is, so the total, so Rm equals is so 2 carbons, so that's 24 plus and 16 times 4. Okay, so that's 4 oxygen, so that's 16 times 4, and that's 64, and that equals 88. In other words, so what is the difference between that part, fragment of the molecule, and that? Okay, and the difference is 104 minus 88, which equals 16. Now, this 16, what kind of a molecule has a mass of 16? Now, the more you practice these kind of questions, the more you'll be able to do this easily, because I know immediately, because I've been doing these questions for a long time, I know immediately that 16 is a methane, right? So CH4. Okay, so obviously I can't put CH4 here though, because if the CH4 needs to be bonding to this oxygen, then it needs to lose one of those hydrogens. So there's your methane, and of course, so that carbon has 4 bonds. Okay, so now if I'm going to add that to this oxygen or this oxygen, which is the only place where this can go, that means I need to lose one of the hydrogens. So that means I'm going to have C H H H. Okay, but then again, it's not going to be 16. This is now 15, so I still need to add the other one. And then you realize, hold on a second, the only way I can have an extra hydrogen is if I put a hydrogen here, nowhere else. So that means there is no other place that hydrogen can go. So if I put hydrogen there, now I've added 16 to this 88 to give me 104. So obviously what's happened is that one of these dioic acid groups, so one of these acid groups has esterified, the other one hasn't. And so the question, let's look at identify the species responsible for the 2 peaks. Yeah, so the species for the 2 peaks, so the species for the MZ equals 104 peak is literally, now you can draw it as a displayed formula like I've done. However, you need to get used to sort of structural formulas. You'll get the mark, it's not a problem. But with one thing though, yeah, you will get the mark with that, but you got to remember to do one thing, okay? But you can draw a displayed version or a structural formula. So structural formula I'm going to do is as follows. So it's obviously COOH, so and then COOCH3. Now this is the fragment that gives you a peak mass to charge ratio of 104. However, remember, in a mass spec, you don't see neutral molecules, you see ions. And as far as you're concerned, you see positive ions. So that means you've got to have the whole thing in square brackets with a positive charge. If you miss that positive charge out, you will lose this mark, because mass spec does not show you neutral molecules. It shows you ionized molecules. Okay, so, and even if you want to draw this displayed formula, you still have to draw square brackets around it and put a positive charge, otherwise you won't get the mark. All right, so that is your 104. Now, what about, so that is done. Now, what about the 118? Well, mass to charge ratio of 118. Similarly, so what I'm going to do is very similar to what I've done before. So I'm going to start with that. I'm not going to redraw that dioic part of the molecule again, okay, because you can see it here. So similarly, I'm thinking, okay, well, this is, we know is 108, you know, no H's and no CH3. Now, common sense would say, can I get 118? So can I get this 118? Maybe the other carboxylic acid is also being esterified. So if I have a CH3 here added, so remove that hydrogen but add a CH3, does that give me a 118? So let's find out. Okay, and I'm just going to do it on the, I'm not going to write anything down, I'm just going to literally do it on the calculator just to find out. So it's obviously 88 plus 15, right, not 16, 15, which equals that. And if I add another 15 here, remember I'm removing the hydrogen, right, plus 15, yep, fair enough. That shows you, you know, that gives you 118. So that means the second peak is obviously due to, and I'm going to draw the displayed diagram here. I'm going to draw the display diagram and then I'll draw the structural formula. So obviously this side is also, yeah, so you have a diester. Okay, and that of course, now obviously I'm going to remember it's a peak that I'm seeing. Well, I'm sorry about the mess, but anyway, I'm seeing, so it's got to be drawn as a positive charge. Okay, and of course if I want to rewrite that as a structural formula, then what I would do is literally, I mean there's a number of ways you can do it, but you've got to remember to leave a little bit of gap, yeah. And then of course on the other side it's also, and of course I've got to draw square brackets, and that or that, you don't have to draw both, that or that, yeah, is the second peak. Okay, now just I'm going to say something for Edexcel, which obviously my students aren't doing, my students are doing AQA, but for Edexcel you don't need to be able to describe the sort of time of flight, how it works, etc., etc. But for AQA students, you not only need to describe how time of flight mass spec works, but also you need to know both techniques of ionization. Yeah, so that's electron impact and electrospray. Okay, so make sure if you're an AQA student, obviously look at your syllabus, isn't it? Yeah, but I know that you do need to know both electron impact. You don't need to be able to describe necessarily. However, you need to know what kind of ions you get. Okay, how does electrospray work? You do need to know that for AQA students. Okay, how does an electron impact work actually? I think you need to know that as well. But for Edexcel, in the specification, it does not say that you need to be able to describe how a time of flight mass spec works. However, you do need to be able to analyze mass spectra, and usually it's an electron impact mass spectra that Edexcel questions are based on. Okay, and I think the specification actually says the same thing, that you need to be able to analyze the mass spectra, okay, of ions, okay, and usually the mass spectra they gave is electron impact. Okay, so listen, so this is the only 2 marks. Can you see why I said to you, even though it's only 2 marks, but there's a lot of previous information that you needed to have. Okay, students where they often lose marks, well, they will miss out ions, so they'll literally write the fragment there without the positive charge, and therefore they lose a mark. Okay, they might end up silly mistake in terms of calculations. Yeah, yes, I've seen that. Yeah, silly mistakes. Yeah, come on, you know, you should know better. Yeah, you learn how to use a calculator, right? But the thing is, they do make, because like, remember, it's under pressure, isn't it? Yeah, there's a lot of pressure in the exam, so you know they make silly mistakes or on the calculator, and they're in a rush and they're doing that, and they press, instead of 16, they press 17, and then they're struggling. They can't match the 17 fragment. Okay, so be careful of the maths in this kind of question, and of course, if you are going to write down the displayed structure, then please, I know in the lessons students often omit these hydrogens because they just draw these dashes and assume, yeah, of course there are hydrogens. But if you do that in the exam, they will penalize you. They might penalize you once per question or something like that, but they will penalize you. Okay, so if you are going to do displayed, yeah, please make sure you don't just leave these as dashes. Okay, you put down the hydrogens as well. I have gone through a question which includes sort of a mass spec and also IR data as well. If you want to learn how to do those kind of questions, where they use IR data and mass spec, you'll find it here. Okay. Well, don't forget, you think you know this question, you know how to do it. You won't, not until you practice. Remember, this is my sort of saying that I always say to my students. You think just because you've seen me do it, you think you know exactly how to do it. You know? Why don't you try this question yourself, okay, and see if you can do it without my advice or my help. And if you can do it, practice some more. Okay, well, I hope that helped. Try the questions, and I'll see you next Tuesday.